Hello, good afternoon, and welcome to Live Coding with Gerph, episode 5 I think we're on. Oh, 6 it might be actually. I think we're on 6. We're on 6, it's amazing. People can hear me, so this is all good. So let us go through what we're trying to do here. So, I am porting I have ported a disassembler, which will be used inside a RISC OS module. So I'm building up a new RISC OS module called Debugger, which is intended to replace the standard debugger, and it is based on a open source disassembler that someone wrote. It's a BSD license, and I'm just making it work for RISC OS. The disassembler part is pretty much, well, not done, because there's still some ugliness about how it outputs things, and some of the floating point instructions, or all of the floating point instructions, aren't actually implemented yet. We've got a few people on the stream, this is great. So we will need to do the floating point instructions at some point. We have a task board that says all the things that need to be done. So there's a list here of 9 things that haven't been started. And we've got a in progress. The thing that we had in progress last week was adding the debug operations. Now, I thought, oh, those aren't important. I know it's called Debugger, but it's actually pretty useless as a debugger, in my opinion. However, when I asked people about this, they went, oh, yeah, that's really useful. Paraphrasing. So I'm trying to make it work. I mean, it's all going to be a work in progress anyway, and people can have a go at playing with it as well. But the debug operations seem to be important to people, so we're going to continue with those. At the moment, let's just see if there's anything written on the ticket. I think I did write something. Yeah. So break set, break clear, break list, continue, and debug are the commands we need to do. As I asked people and they said yes. Fair enough. So what we've been doing last week was implementing break set, break clear, and break list. So we have a look over at some of the code here. We've got breakpoint handling here in this file. Let me just make it full screen. Yeah, so we've got breakpoint handling in here. So this basically has a prefetch handler that we handle. This annotation function is used inside the star memory I to show us which breakpoint was being set. And then there's breakpoint set and breakpoint clear and breakpoint list. So these are just simple linked list manipulation. They're not particularly difficult. There's still some notes in here that say we probably should do some things. It's not too terrible. People can have a look at that as well. I'm hoping that once I've done some of this, I'll be able to not necessarily hand it over, but well, I'd like to hand it over, but I don't know whether anybody else wants to take it on. But pass it on to everyone else so that they can actually try working on it and finish it off. Because I'm not going to get everything done in here. I've got other things I want to be doing, and that it's actually more useful for me to be doing. At least I think, anyway. So I'm trying to get it to the point where it's actually like kind of useful, and then people can take it on from there. So, as I said, we have a breakpoint handler. Oh yes, so let's go through the reasons why I've got a breakpoint handler on the prefetch abort instruction. So if I remember correctly, and I'm working largely from memory because I haven't really looked at how the old debugger worked, because it's an ARM 2 basically, a debugger for ARM 2, it didn't have a breakpoint instruction. So what they did instead was they branched into the right environment, and that meant they could capture all the registers okay and it wouldn't be a problem. But that has a limitation that you can't you can't branch more than 26 bits worth of distance. And if your module area is really high, like say it might be on a 32-bit system or others, you might find that not work. You might not actually be able to install the breakpoint. That's 26 bits backwards and forwards, so 25 bits forwards, 25 bits backwards. So I decided to use the breakpoint instruction. So we actually use the breakpoint opcode. Breakpoint has a 16 bits. Yeah, I think it's 16 bits reason code, and we use that reason code here as part of the breakpoint identifier. So all breakpoints that are added have an identifier on them. So we have a limit of 65535 at the moment. That will wrap, but it doesn't handle the case of it wrapping at the moment. That can be fixed later as well. And we put the breakpoint number into the instruction. And the reason that we do that rather than just remembering the address that the breakpoint was installed at is that the code might have been copied. Now that might not matter for most of the things, because most places when you breakpoint things you won't end up with the code being copied. But in particular, the set varval handlers, when they register a code variable, will copy the code. And because of that, I thought it's worthwhile as actually putting it into that particular instruction, into the instruction rather than just remembering the address. That is the reason. So we have a breakpoint handler, which is in the prefetch abort handler, which is in this chunk of assembler here. And it's not particularly nice. I will say that wholeheartedly here. So let's work through what it does, because prefetch aborts are complicated. So first thing, the breakpoint instruction, breakpoint, I'm going to call it breakpoint this time around. The breakpoint instruction, when it is hit by the interpreter on the chip, it triggers a prefetch abort saying I can't execute this. And it will also set the IFSR, the instruction fault status register, to say this was a fault, it was a debug fault. There's a number of other faults that can be reported in the IFSR, like abort whilst trying to walk the translation tables at various levels. There's different messages it reports for that. And it can also be triggered as an instruction fault from externally as well. So if you had a co-process that was producing faults, it can interrupt you and tell you that there was an external fault. And that can also be used for things like watch points and the like, if you've got JTAG on some systems, I believe. Never worked with them, so I could be wrong on that. So it sets the IFSR to have the debug flag set, and this is what we read here. We read the IFSR here. And then we go and mask off the bits that we need to know, which are just the what type of FS is it, fault status. We AND that out, and then here we go and check whether it's the debug one. If it is, we branch all the way over to here to get the breakpoint handler. If it isn't a breakpoint, however, it's not a debug, then we go straight back, we restore the registers, and we call into the original prefetch handler, which we've handily stashed away in this workspace. Okay, so the very first thing that I did to test this was to make it just go and crash, because if it crashed, I could then see that we'd actually entered our code and recognized that this was a breakpoint, and that worked. So the next thing to do is to go and try and store the state. So here we go and load the address of the register block we are dumping the registers into. We stashed all registers R1 through to R12. Cunningly, we've already stashed R0 on the stack way up here. And that means that we can just pull it off the stack down here, and we store it into the exception dump area. Next, we get out the old version of the CPSR, the current process state, in the saved processor state. So we've been entered here in the abort mode. So we're actually on the abort stack at the moment. So we store the saved processor state as the CPSR in the register block. We then read the address that we faulted at, which has got to be the PC at the time of the abort, and we store that in the exception dump area. So now we've initialized R0 through to R12, R15, and the CPSR. We then just unstack by skipping over the preserved registers, because we're about to jump out of abort mode and into SVC mode, and we can't leave the stack filled. We go into SVC mode by just manipulating the PSR and enabling interrupts. We need to enable interrupts because we're now going to try and get the user to give us some input, and if we don't have interrupts enabled, we're never going to see their key presses. So we're now in supervisor mode, SVC, and we can now go and stack the extra registers. So we stack R0 and R14. R0 contains currently our exception dump pointer, and R14 is R14 SVC. So we store off R14 SVC, which might not actually be correct because it might be the user, we might have come from user mode. If we've come from user mode, we're going to have to fix that up, which we can do in a little bit. And we also store the old R13 SVC. Again, that may be incorrect. And we print out a message saying we've hit the breakpoint, call a new line, and then we just go into GOS so that we get a command line. That's where we're up to. So, having got there, and that was a long explanation of where we were, let us try and run it. So, okay, let me see if I can remember how we do this. Okay, so we need to do pyro dev. Oh, hang on. Give me a moment. I've got to go and make pyro work again. I've almost certainly gone and broken things. Just give me a moment. Let me stop the camera. Boom. Git stash. Check out master. Pull. Here we go. And hopefully we should be back in a place where we can now run things. So, not that stuff, please. I want the bits that were running our module, RM32 debugger. There we go. That's my command. Yeah, I wasn't quite ready for this because I was busy making pancakes earlier. Oh, undefined instruction at some address. Yes, all right, I know what that means. It means I didn't actually clean everything. Make, clean. Go back and try running it again. Come on. Nope, still failing. Did I not actually check it out? I did. Oh, I checked out the wrong bloody code. Check out master, stash, check out master. This is what happens when you're not paying attention. Pull back over here, reload the code. Doop, 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 doop. Yay! We've got something. So, memory I 8000. There's a whole bunch of nothing in there. Break set 8000. Go 8000. That'll start running at that breakpoint. And we report that we've hit a breakpoint. And then, if we just do show regs, that's where we got to. That was wrong because the PC is currently 0. And I don't think that's right. Is it right? So we came from GOS, and GOS doesn't actually have any state in there. It's possible. Oh, PC is the PC from R14 SVC, isn't it? Yeah, R14 SVC. No, IFAR. It was AFAR, so it should actually have been correct. That's annoying. That is very annoying. All right, let's try debugging it. Pyromaniac, debug, plus trace. Turn tracing on. And then go 8000. Right, let's make this window a bit bigger. So what we did was, here's the bit of code that did some processing in, not sure what they're in. That's the default upcall handler, and then those are probably in a bay or something like that, a bay and basic or something. We call the breakpoint, and then it enters our code. We do the IFSR. We see whether it's got a value of 2, which is the breakpoint. Yeah, we're in a breakpoint. We go to here. This stacks all the registers. This stacks R13 SVC. Okay. No, this stacks R0. Sorry, this is R0 from the time of failure. SPSR gets stored in the register block. Oh, that's interesting. The register block. Is that the correct register block? I'm not sure. I'm not sure. And then we read, where is the IFAR? IFAR, that's this one here. Yeah, so that's read R0 equals 8000 there. So it shouldn't. Oh no, hang on. Store R0 at R0, comma. That's not going to work. Yeah, I've corrupted R0. That should have gone into R1, and I should be storing R1 here. Oops. All right, well, that's fine. We can fix that. There we go, it's back down there. So instead of reading the IFIR into R0, we need to read it into R1, there, and then build that, and run it. Let's try that again. Right, break set 8000, okay, go 8000, hit a breakpoint, good, show regs, PC 8000. Excellent. So now we've actually got the program counter coming out correctly, which is kind of useful. Just give me a moment. Oh, no, that wasn't what I meant to do. Just trying to quit things to get a bit of speed back on my machine. There we go. No! Rather fun. If you click on the background on latest versions of macOS, I'm not used to it yet, it goes and moves all the windows out of the way so you can see the backdrop easily, which is really handy if you wanted it, but if you didn't, it's like, oh, everything's just gone away. Right. So, we know that SP is wrong and we know that LR is wrong, because those are the SVC versions of them, and we're actually in user mode, or we were in user mode, sorry. So I need to actually get out the R14 user and SP user. And I can't remember, I kind of remember how to do that. but I'm going to ask people to shout up if I have got it wrong, because I have almost certainly got myself confused. Actually, because I can do this, let me just go and put the SPSR into R2 here. Because if I put it in R2, I can use it down here when I'm in SVC mode. We might have been in user 32 when the abort happened. So the R14 and the R13 we stashed will be wrong. So, and R14, comma, number mode mask, TQ, R14, comma, number mode SVC 32. BEQ, if it was 32-bit mode, then we're already done. So we're using, so this is, hang on, let me make it bigger. I can see what I'm doing better then. That's better. If we are in SVC mode, then SP and LR already stashed. There. Copy that. Oop, no, I pasted it in the wrong place. Right. So, and oh, sorry, not R14. Sorry, I don't want to look at R14. I want to look at R2. That was the reason for putting it into R2 when I was up here. So in R2, it'll come all the way down to here, and I can then check. So TEQ R2, comma, number mode user 32. Actually, IRQ is the only other mode that would make sense for it to crash in. Honestly, if you've set yourself a breakpoint in something that executes in IRQ mode, what do you expect? I mean, are you really expecting things to work? You've left things on the IRQ stack and... oh. Okay. Was in IRQ 32. Fix me. Oops, not semicolon here, is it? Dark hash, it's semicolon. Fix me. We don't handle breakpoints in IRQ 32 yet. It's safe to call swise here because we're already in SVC mode. We've stacked away everything and we should be safe. Breakpoint called in IRQ mode. IRQ R13 and R14. Comma there, that's not right. Are invalid. Also, the machine may just crash at this point because you've got IRQ handlers that are breakpointing. Where we were in user 32. Add R1. Comma R0. R0 contains hang on, is this garbage? R0 here contains the pointer to the exception dump. We stack the exception. Yeah, that's okay. Sorry, I was just getting confused. I thought, for some reason, I thought that was an LD rather than ST. Yeah, okay. So we want to move the stack point, move the pointer up to the point where we've got, we would be storing R13 and R14. I believe this is how you meant to do it. And then you do stm increment after to R1. I don't need to increment it, of R13 and R14 with a hat. And if I remember rightly, if you use the hat on an STM instruction and you're not in user mode, the registers it goes and stores are the registers from user mode. That only happens if you don't do post increment on the base address. I hope I've explained that correctly, and I hope that one of the people online at the moment will correct me if I'm wrong, because it's been a long time since I've had to deal with this. Store the value of R13 user and R14 user. Got a not a freaking clue from Dave. Good. Okay. Well, let's see what happens. All right. So we know that. So we're now going to branch over this, and we're going to go SP and LR already stashed. Okay. Let's see if this works, shall we? We're all learning together. It's great fun. Build it and run. That ain't an instruction. At least not in ARM. It's a thumb instruction, I think. Actually, I probably don't think it's even a thumb instruction. Oh, okay. IRQ is mode number 2, I believe. Oh, I have all 7 defined. So IRQ 32 is 2, and actually, I'm not sure it is 2. Mode IRQ 32. Surely somebody must have written that somewhere. Yeah, they have, but they've all written it in. I think that looks right, actually. It's on the RISC OS Open ticket. That's handy. Yeah, so IRQ 32 is a number 2 set, which is good. I'm glad I remember some things. I think FIQ is 1 then. So this is user USR 0. Okay. Break set 8000. Go 8000. Hit a breakpoint. Show regs. That looks more like it. I think that looks like the address of the. Oh, hang on. I'm in user mode. Let's do this from basic. So, I don't know what to do here. Let's just. What the heck? Let's just start break set 9000. Call 9000. It goes in supervisor mode, and then show regs. That looks like it might be the right address. That's definitely a stack pointer that's in application space. These sort of look like values that I might expect from basic. In fact, if we go back into basic again, 8% equals and 9000. 90,000, B% equals 665544, C% equals 998877. No, in hex, please. I think we go all the way up to H%. I don't actually know how high it goes. Something like that. Okay, call and 9000 again, and show regs. Yeah, I think it goes as far as H. So 900,000. PC was 9,000, and that looks good. Just need to know that address. So 1F520 modules. Basic. Yeah, that looks like it's inside basic. 1F520. Somewhere between basic and obey. I'm feeling good about that. Okay. So, with that, we now have prefetch handler, which will go and store all the registers to the correct positions. And when we're done, we need to go into some sort of handler to say, I'm going to run these things. So, yeah, I guess we need to do something with that, don't we? Ugh. Right, so I think the best thing to do here, I'm just trying to think. So I'm going to want to be able to do a bunch of commands inside star debug. So we need star debug to have a basically a command loop that we execute commands in. That's not going to be very difficult because we just call read line and then execute it and repeat. So that we can do. But when you execute star continue, it needs to exit the debug command and then return to continue from where it left off, changing mode to the right place. I think I'm going to get around this in a relatively easy way by just implementing the star debug command. Ooh. Can I run star? Can I just change this to star debug here? Yeah. I think this will actually work. I mean, we don't have a debug command at the moment, but we will be able to do this. And if I add in here a little word that says should we continue where we left off? So this is going to be a flag that says star continue was used, basically. So, where is our workspace? Oh, our workspace is just here, so I can just load from it. That's easy enough. Actually, I could probably have set R12, couldn't I? I could have probably set R12 to point to our handler workspace, since we don't really care. Oh, except I haven't stashed things by then. Yeah, it doesn't matter. Oh, pointer's juddering all over the place here. What's going on? Right. Oops, no, selected too much. Copy this line. Put it here. General 8. Right. Back from star debug. Need to check if we continue or not. star continue was used. Actually, we probably should clear it before we actually even enter this so that we don't accidentally go and continue. So R0 common number. Actually, no, it doesn't matter. I'm trying to think too many steps ahead and it's hurting my head. One of the things I was also thinking about how we might do this in the future is that instead of calling star debug here, we might actually issue a service to say there is a pending debug operation present, anyone want to handle it? And then another system could pick that up and try using it. At least that's what I'm sort of thinking we could do there. And that might allow us to have a proper debugger take over at that point. We could even have a proper debugger that was running on a separate processor, because we've got that now on many of the systems. Anyway, in fact, I'll leave a note to say we could do that. We could issue a service to say that debugging has been requested. Yeah, I'll just leave it at that. And this actually isn't fixed anymore. This is we call star debug. Should that be exosly? Probably. Branch of reset. So one interesting thing about this is that up here I've left R0 and R14 stacked. If I remember rightly, though I could be wrong, that probably will also prevent the triggering of callbacks, transient callbacks, that is, which might be interesting. Anybody know what happens if you start using the breakpoints inside task window? Does it work? Is the system actually like able to function? Again, I don't use them, so I don't know whether it's actually like sane to even do that. I'm guessing it probably will be, but I'm not really sure. Anyway, that's something that somebody could try at some point. I wouldn't be surprised if it takes out the machine, but I suspect somebody has tried it and it probably does work. Right. If we were not debugging, then we need to exit. Leaving debug through OS exit. I mean, there's not a lot else you can do at this point, because you just have to hope that the system will recover. And if it doesn't, then, well, you are a bit stuffed. Right. Here we need to go and restore all the registers, which actually isn't as hard as you might think, because all you need to do, it's always a great phrase when somebody says all you need to do, is we load the address of the exception registers. load R1, oops, comma number, not number, R0, comma number 16 times 4. Load old SPSR. What's the best way of doing this? Is it to select the mode first? Yeah, I think we should select the mode first. I'm going to assume that the exception dump area continues to be readable in user mode. That's not always true. So we assume that the register dump remains readable. Because it might not be. MSR, CPSR, I can't remember what the sequence is. All was so much easier. CXSF. Comma R1. So that'll put us into the target mode, and then we do LVM-IA, load all the registers from R0 into R0 through to R15. Restore all registers. I think that's right. Never reach. Yeah. And that's nearly it. There's actually a bug in it because we've still left 2 registers stacked on the SVC stack. We've stacked R0 and R14. So let's just unstack those. Paste. I'm hoping this is making some sense to people. Unstack. I should work out what the stack ordering is so that we actually put the correct signature at the top of the stack, but I can't remember what it is, and it's not actually important at the moment. There's a fix me note about that. Right. So we've now got the return implemented. I now need to implement star debug and star continue and be able to set the flag. So let's go back to the mod head file in CMHG and we can edit things. Random person from India. I am not sure what they're trying to say. Sorry. Let's add in star continue and what's the other one? Star debug, which we should be able to do relatively easily here. Right, debug, min-args 0, max-args 0, add syntax, invalid syntax is syntax star debug. Help text used internally to do something. Oh, this is quite handy actually. So somebody could actually alias star debug to be something else, and it would go into somebody else's code, and then they could do something else with it. So you didn't even need to have a service for that. That could be quite cute. By the command line, when a breakpoint is reached, I've gone too far. Everything's gone slow again. I'm not sure why. And finally, handler is command underscore debug. Continue. That was the other command. Continue. This is almost the same. Continue. Oops, let's change that as well. I missed the colon, didn't I? And I missed a colon there. Continue execution after a breakpoint has been reached. It only works within the star debug command. No, it doesn't. It doesn't only work within star debug. It works within. Only works within a breaks when a breakpoint has been encountered. Somebody else can work out the wording on this. I'm sure there's better ways of writing that. Anyone wanting to provide more input to the project, please go to the GitHub repository for Gerph/DARM, and you can raise issues on it there. Please feel free. I mean, it's there for everyone to have a go at, and I'll be happy to take any pull requests, suggestions, comments, bug reports, anything you like. And probably pineapple juice as well, although I don't think you can pass pineapple juice through issues. If you can, that's cool. Right, so we have the debug command and we have the continue command. I now need to go to the C code for the veneer. Where's the veneer gone? Here we are, veneer. Right. Because we're going to provide a new command. So jump to the end. Let's copy the code from show regs. because it's nearly exactly the same. Well, not the same. It's just it's got the same prototype and bits. So. Okay. Actually, we can do star continue, because if we implement star continue first, that'll be a lot easier, because star continue should be a very simple operation. All we need to do in star continue, not that one, I wanted the other breakpoints file. Oops, no, back to here. Get prefetch handler workspace. Workspace to continue equals 1. Oh, I can't use the word continue because continue is a keyword. I will just got cont instead. If we were in a breakpoint and the we're in a breakpoint and the star debug is running, we will turn back and continue prefetch. Dave says, interestingly, Swift lets you use keywords if you escape them with backticks. So you could do backtick, continue, backtick. That's... Okay, so... C is not quite so friendly like that. Clearly. While. Actually, I want to do the same thing here, don't I? Copy the prefetch handler workspace getter. While workspace to cont. Whilst they've not said continue, read a line, execute it. That's pretty much it, isn't it? Oh, hang on, we probably want to print out a prompt to warn people that we're actually in the debug handler now. Os write 0. Entering debug shell. Debug shell a good name for it? Dave also says other modern languages are available. Yes, yes, I know I'm using a very old language. Sue me. Taylor says after the 1990s, you mean? Well, I guess, yeah, I am using C89. It is. Let's move on. Sorry. Oh, I'm forgetting what I'm doing. Right. So we're just reading a line and then executing it. Actually, this is very similar to the memory A loop, isn't it? Where I call os read line. Is that in here? Memory A. No, where's memory A? Oh no, it's in here. we actually call a readline function. That's nice. I can use that. Dum, 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 dum. Let's just pinch that code. I'm going to make this static here because anybody trying to run this sort of thing in an environment where there are multiple instances needed of the breakpoint handler, you're almost certainly going to fall apart and fall very, very, very flat on your face. So yes, I think we're just going to read a line. So there we go, read a line. If we weren't successful, something went wrong. Give up on the shell. And then execute it. Literally just oscillate, isn't it? Probably want a prompt here. Os right 0. Boom. I think it does something like debug star. I think that's what it normally does. And then we read a line. And then we execute it. Yeah, that seems about right. I mean, honestly, this could just go very, very bad. If ws cont 0 continuing. Else, did we already have a printing out of the exiting? Yeah, we already print out the that we're leaving debug, so I don't need to do anything for that side of it. Already printing. Maybe they should be consistent between the two, but it's not going to matter. I keep saying it's not going to matter. It probably will, and people can try and break things in the future. No idea if this is going to work. Genuinely not a clue. The answer is isn't going to work. Into the prefetch handler again. Okay, so let's exit. I'm going to guess at OX 11. What do we reckon? Kitten, not kernel. Size. Let's exit. Hex 11. Spot on. What was the other one I needed? I've already forgotten. Oscillate. Oh, except I've already got oscillate, I just haven't got an X oscillate. And they're already calling it X oscillate anyway, so that's fine. Just change it to be Oscar. Andrew says, good guess, you win a pineapple juice. I have my pineapple juice. It's always good. That, however, was not so good. Prefetch workspace. Is prefetch workspace only defined in the breakpoints? Maybe it's in the header. Not sure. Hang on a second. Being offered tea, but I'm actually quite good at the minute. Which I've now said, so I didn't need to write. Communication, it's awesome. Where was I? I was trying to find the prefetch workspace. Prefetch workspace 2. Sorry, Taylor just came back with, I'm watching you in the other chat. I'm easily distracted. I'm going red now. So embarrassing. Is it in introspection then? Actually, why am I trying to? This is the whole point of this, wasn't it? Star.h.star. No, h/star. Oh, it's in the prefetch header. Okay, then. We'll just include the prefetch header then. Include. Now, if I was really good, I'd have one of those editors that does all the whole fancy where tags are and things. It would tell me where these things are and I can just ask it. But I'm not that good. Inventing os write 0. Do I not have those calls defined? Apparently not. I thought I did something with those. David says, yes, we have those editors here in 2024. Yeah, I was still coding in the 90s. It's, yeah. I'm working my way up to fancy editors. I mean, I'm not using Zap. You've got to give me some credit. I like Zap. Right. uint 32t cont. There we go. Right, so that's my prefetch handler, that's that thing. Now I've not got any of these functions. Tilly says he still thinks we're back in college. Well, some of us would love to be back in college and unwound a bit of that time. Maybe. Maybe earlier, younger me would be just as stupid if he did it again. Let's try not to be too melancholic. There's obviously a reasonable degree of melancholy that's necessary for coding with Gerph. Int success. Right. Now I've just got me other commands that I've missed. I swear I'd done some bits with that. Did I not do something in show regs? Right, C, right. So where are they defined? In IO. Right, right C, and right lun. Oh, actually, if I've got right lun, that makes things a bit easier as well. Yes, I could use fprintf, but actually I could use fprintf, couldn't I? Yeah, it doesn't matter. I think probably it's slightly better to not use the studio type output inside the breakpoint handler. I think maybe that makes sense. I realise I'm also post-rationalising these things, so yeah. What the heck? Bosley, comma, E0. There we go. Oh, except that if an error occurs, we want to report it as well, don't we? So let's just do that. Equals if we had an error, excuse me. Right, error. Mess. Right. Maybe I miss having printf. Actually, that could be right link, can't it? Okay. Did I not just define success? 292 success. Success. Oh, apparently you have to spell them both the same way. How do you spell success? That's right, isn't it? Oh, and I haven't included IO. Wow, this file's got quite long now. It's possible that some of the commands could be split out into a separate file. Line 311, somebody's just pointed me to. Nope, not there. There's a null there. Sorry, Jeff, I'm not sure which line you're referring to. Have you noticed how much you look at a word, the more you look at a word, the more wrong it looks? So many times. Get very, very confused. Oh yeah, it does say line 300. That's what Jeff was pointing to, the fact that success was on a much earlier line, 312. In this function, I have defined success and I've not actually used it. Yeah, there. Well, let's get rid of that whilst we're at it. There's a bunch of others as well, but since that one was pointed out, yeah. Thank you very much, Jeff. That is a... At least I've got something else fixed now. Let's try it. Let's give this a whirl, shall we? Okay, so... in order to actually breakpoint something and then be able to continue, I've just realised my continue is garbage, isn't it? Because what I'm going to do is I'm going to continue not executing the instruction that I've replaced. Oh, bother. Oh. Okay, so let's... I know how to do this. It's evil. Let's actually just see that we get something that works to begin with. So basic opt 2 3. Hang on, what those are? 2, I think. I don't think it matters. Swy os right. Actually, 106. No, 100. P. Swy and 100. Actually, what we'll do is we'll not use P, we'll see O and K. That's a good idea. O and K, and then return. Okay. Oh. Right. So, if I call 9000 now, we get OK, OK. Why do we get OK, OK? Because I wrote it twice. Start it there. Actually, what I'll do is I'll put them all on one line so I can use my history in the future. That's too much. There we go. Right. Now if we call 9000, break set 9000. Call 9000. Hit a breakpoint, entering debug shell, start debug. So we should be able to run commands here. Echo hello. And we should be able to do a continue here. It'll work. Continuing from a breakpoint, hit a breakpoint. Yeah. We continued at the actual breakpoint. So it went and hit the breakpoint again, and we entered the breakpoint handler. It was a bit stupid. Yeah, so we do need to execute the command, and we need to increment the address that we're executing at by 4. Okay, so this is going to be tacky, but let's give it a whirl. So Andrew suggested, Jeff suggested a couple more things. They clean up. I will clean those things up later. Oh, except value is set but is used before being set. That's actually not so much cleanup as actually a problem. Hang on. Value, maybe that's actually a problem. You're right. Let me just have a look at that one, and then I'll come back to debugging things. 311. That's probably been a problem for a while. Let's see. Value may be used before being set. Value. Oh, I know what this is. So yeah, we came across this one before. This is because value is also shadowing interactive at that point. So if interactive is non-zero, it can't ever enter the loop where value is used. So it was actually safe, but that's fine. We've now I've added the code in to make it safe now. Thank you. Andrew says, can the continue command reinsert the 9000 command at 9000 before continuing? So I could, but if I do that, then the next instruction would have to be breakpointed as well, because we need to execute just one instruction, then put the breakpoint back again, which is going to be complicated. Either way, it's going to be complicated. So I'm going to do it a slightly different way, which will leave the breakpoint always in place, which might be the wrong thing. I'm not sure. It's S code I want. Sorry, I want the assembler code. Prefetch, please. Right. I'm going to do it a different way, and maybe this will work. Maybe it won't. If it doesn't, I may have to do it Andrew's suggested way. Old instruction. This is the one we're going to execute. And then LDR PC, comma, the next thing. So the idea being that we'll jump to this old instruction here, this instruction here, and it'll execute whatever that did, and then it'll jump to whatever the next address is. This won't work, therefore, if we've got a branch link or something, or just a plain branch or conditional or something. So it might be a bit odd. Yeah, let's try this and see what happens. We're winging it. Let's see what goes. uint32 old instruction. uint32t. This is the LDR PC next word. Continue at. Okay. Yeah, so we go back down to veneer and the continue command, wherever that's gone. Continue command. Here, right. Okay, so oh, you know what? I haven't identified which of the breakpoints it is, have I? I haven't identified which breakpoint it is. But what I could do, write it in here. And then we can pull it out later. So that'll mean in our S file, we need to store that breakpoint number. Yeah. Actually, I'm not going to store the breakpoint number. I'm going to install the breakpoint instruction, because then we'll do all the decoding outside in the C code, because then I can write it in the same language rather than having to get myself too confused. So that's the IFAR, LDR R2 comma brackets. Read the instruction, store R2 at... I've reordered the blooming workspace, haven't I? +8. And that needs to become +12. Whether we should continue. Load the exception registers. Right. And I want to do right, so that addr will then jump us to, well, if I'd spelt it right, it would jump us to the right place. That will start executing the instruction that was needed and the actual code. This here is going to do something. I need to read what the R15 would have been. No, not like that. So read R15 what it would have been. Breakpoint location. Step over that instruction, because that's important, otherwise we just breakpoint again, as we saw. Step over the breakpoint, store that prefetch handler I'm regretting not giving these symbolic names. 24. Plus 0, plus 4, plus 8, plus 12, plus 16, plus 20. I can't add up. No, because this is also not consistent anymore, because this is actually exception. This one is breakpoint instruction. Whoops. Really regretting my choices. This is not the way I should have done it, but I could clean it up later. putting words in the wrong place. Ooh, what time is it? Yep, it's nearly time for a break. I think my head is starting to get a bit confused. Plus 20. Right, so yes, that's plus 24. This is plus 16. That's right. That's right. Plus 12 is the star continue address. Yes. Okay. Ideally, this stuff should live in the workspace for the module, not in the actual code, because this won't run in ROM. Not that we really care about things that run in ROM for a lot of the cases, but the debugger module probably should. It could be moved. It's definitely not the end of the world. Right, so that's going to store the old instruction. We've got the continue at. So what we need to do here is decode the instruction. WS2. Did I update the? Yes, called breakpoint instruction, isn't it? I think in the breakpoint handler here, I've got an extractor. That's cool. So actually, if I just write a quick veneer for that, there we go. Are the breakpoints only defined in here? No, they're not. Breakpoint underscore t star breakpoint or find by instruction. Number equals bit extract from instra, and then we need to find it in the list. Find the breakpoint in the list, return breakpoint. Actually, don't even need that indented there. BP equals breakpoint find by instruction value. I'm just refactoring this because it's the same code. I've literally just pinched it, so I know it's the same code. So I can get rid of all of that, and then all of this just becomes a simpler like that. And then we can document this. Breakpoint find by instruction. Instructions. Into Dave has suggested, I wonder if it's worth having an instra T and an addr T. It won't catch anything, but it's more like self-documenting. That's probably a really good idea, Dave. Yes. Gerph has also suggested that the two breakpoints can't have two breakpoints pointing in the same instruction. That is correct. And in the add code, I've left a note saying that, where's the add code? Set code, yeah. We should check that the address isn't already breakpointed, because that would just cause us to loop around. We should. I've not got around to doing it yet. But that seems like a good idea. In fact, that's probably worthwhile. I should bug that. All of the fix me code comments, rather, should be looked at before we get any further, get too much further. Because most of this is why I leave the fix me marks, because I know that there's something that's wrong, but that it's not going to work properly in certain circumstances. But it's not important right at this second to just get something working. Excuse me. So breakpoint _t equals breakpoint find by instruction. Or breakpoint oh, I'm using Lightland, so I don't think I have a decimal printer. That's annoying. Come back to that in a second. If I can write actual C code. So we found the breakpoint there. The continue command needs to do, come on, that's the breakpoint instruction, find by instruction. What did I call it? Old instruction. I think it's called old instruction in here as well. Old value in here. Not feeling very confident with this. Oh, I didn't transfer my new function into a header. Copy this into the header and that will let it check things. Where was it? It was just after annotate. So I've got some other warnings here. Equals implicit cast off pointer. BP declared but not used. That's because I've not printed out the value. Basic. Come on. There we go. Set a breakpoint. Call 9000. Hit a breakpoint. Continue. That worked. It executed the O and then did the K. Okay. With that, I think we're at least at the point where things are vaguely sane. So come out of RISC OS and do a status. Okay, so what have we got in here? Star debug, star continue, breakpoint execution. Git commit minus A. Completed the breakpoint prefetch handler. Ooh. Can be used to breakpoint lines and continue afterwards. The R13, R14 values of the block have now been set up. Oops. Properly and are correct for the mode we returned to. The instructions are executed out of line. This may cause problems for PC relative instructions. Okay. I'll push that, and so you'll be able to see it on the GitHub repo. So that's it for now. I'm going to take a 10-minute break and then see what I'm going to be doing afterwards. I'm not sure what I'm doing afterwards, so we'll see. It's quite possible we may be fixing some of the problems and bits that have been caused by this, but I think that's looking pretty good. If you've got any thoughts and comments, I know Jeff's left some comments about some of the things. Dave suggested about having an instra T or an opcode T possibly, and an adra T. That may help as well. Yeah, that could be quite useful actually in this. Okay, time for a break. Hello, peoplings. I'm back. I'm hopefully still awake. Still working on it. I think because it's a bit warm in here, it's not been quite so conducive to thinking straight at the minute. But I have cooling pineapple juice, and I've just turned the fan up. Hopefully, it's not going to be humming too much at us. Right, so before the break, we finished, in the loosest sense, the breakpoint handling for the debug commands, and I've now gone and pushed that. Since I have pushed that, actually what we can do is we can go and build a release. We might as well. It's not like it's going to hurt us. So let's see what we can do. So, oh, actually, no. Before we can even do that, check out master git merge no ff breakpoints implementation. There we go. Done. All right, and then we can push that. And if we bounce over to here, we should see that it's built or building. How long did it take? It took 7 minutes to run that build. That's quite a while. Yeah, it's fine. So it's going to merge that. That's not a problem. And then once it's merged, we can get it tidied up. Released rather. Sorry, I just noticed in line 144, is that the address of the instruction or the value of the instruction? Line 144, it's the instruction itself, the actual value of it, the instruction we hit. Otherwise, I'd have said it was the pointer to the instruction. I mean, this is another case where having an instra t and an addr t would actually be useful. What I'm going to do is I'm going to add that to the list of things to do, because I think that's going to be a much clearer thing to do. Let's add it to the list, and whilst we're looking at the list, we can tidy it up and finish things off. So debug operations done, which is good. Let's add an item. Use addr t and instra t. I like instra t to mean. Jeff says, so I can't place the 2 breakpoints that are at different locations but have the same instruction. I'm not sure what you mean there. So you can't have 2 breakpoints at the same address because the address is going to be the discriminator essentially, and we couldn't return back to it. But you could have that same breakpoint appear in multiple places. So, for example, if somebody copied, and look, the opcode encodes the breakpoint number. So the opcode is in this form. So I'm just going to the chat. So the opcode has something like, I can't remember what the actual value is. I'll find the value because it's actually useful to be able to see. So the opcodes we use are this one here. So we end up with OX E120070 is the mask point, and so all of the bits that aren't set there, these ones here, and some of these ones, one of these ones, no, just those 3. I missed a 0, that's why. Try that again. I'm showing you, I can't, let me try that again. These 3 nibbles and this nibble make up the breakpoint number. So the breakpoint number is the instruction and the address it logically came from. But the address that it logically came from isn't necessarily the address that would actually execute at, because the code might be copied. And if the code is copied somewhere, we still want the breakpoint to be triggered. Copying the code will only happen in very rare locations, but that's why we have that. Even if we can't identify the breakpoint, we'll still end up entering the breakpoint handler. Yes, I now understand what you were saying, yes. I hope that makes some sense. If it doesn't, then we can try and explain it again. I should probably at some point update the README to explain what we're doing in the RISC OS side of things, rather than the disassembly code. Okay, I was in the process of trying to explain adjt. So use adjt and instrt to differentiate some of the values in the code, types in the code. Let's add that. Add, please. Did that add? Press return. Ooh. Don't know why that. Oh, it's weird. Sure, it didn't do that before. Additionally, if we were to have pointers that were a different width from the addresses, from the instructions, then we'd be able to handle them. There we go. And then convert that to an issue in ARM. There we go. Right. Oh, I also want to actually put things on that. So that's a label. It's not a bug, it's an enhancement. Yeah, it's an enhancement, and that'll do. All right. Ah, here we go. Right, compare the output using Pyromaniac debugger tests. So I've already got a whole bunch of tests for debugger. So we do pyro dev here, dev even, and we run debugger, ffc. So this is the load internal modules. Is that right? I'm a little confused. I thought debugger was actually the test. Oh, hang on. Does it need to take a command? Yeah, there we go. I need to give it a command. Right. So, D to disassemble ARM instructions. So let's do this. Bing. Okay. So if we look back at this now, we can see that this is what the Pyromaniac debugger produces. It's got normal sorts of output on there, and we can see different types of instructions appearing and all sorts of other bits and pieces, and some extra annotations that happen as well. So that's all kind of good. Let's write that to pyro debug text. Come on. Thank you. And now let's have a load. Oh, we also need to. I need C library as well. Let's give you load the common ones. Load module RM32/debugger. And this is new debug. So this down. There. Come on. Right. Pyro debug. So that's what Pyromaniac's debug looks like. New debug. That doesn't look right. What's going on there? It says it's an empty file. Oh, because I didn't give it the D command. Dum dum dum. And the other one. It's quite a bit shorter. Well, let's have a see. How would we look? They look different. So that's partly because they're separate encode. The encoding format is slightly different. Let's actually just. I'll launch the compare tool because it will be a bit easier to read. Pyro debug against new debug. Good, that wasn't what I meant to do. Come on. I'd like to make you full screen, please. Can you do that? Thank you. Right. So, which of these values are actually a problem for us? There's a bit of better annotation here. That one's giving me a decimal number there and a hex there, whereas we're only getting a decimal here. Not too bad. So the LSLs aren't going to be very familiar to RISC OS users, so I think those might need to be modified. It's not hard, I don't think. So we've got OX instead of ampersand here. I think if I was to replace the OX with an ampersand, that would probably make it quite nice. Interestingly, these have not kept the LSL statements there. They've just put them in lowercase. That's not a big deal. These all look okay. ADRA. Yeah, that doesn't look very nice. So it knows that it's relative instruction, but it hasn't encoded what address it's at. So that's a bit of an oddity. Same again for that. Put a hex number in that version and a decimal here. It's fine. Lowercase, not a big deal. Again, PC relative things not coming out right. We can have a look at that, I think. So this is a difference between the encoding of higher and lower. So one is actually coming up with carry set, and the other one's saying carry clear, because it's how you're focusing on those things. And again, that turns up here, and we've got the same relative, PC relative operations. PC relative operations, lower thans, no comment on the end. No comments on the end, that's fine. Interesting, we've lost the P off these ones. Is that relevant? Well, actually, if you were doing 26-bit code, it was, but I don't think it makes any sense on 32-bit systems. I don't think the P bit has a meaning on 32-bit. I'm not sure, anyway. Well, that's an interesting one. Instead of doing MRS, it's actually turned these into SMLABs. That's not right. So that looks like it's actually a problem. I mean, it might be that these are actually some odd encodings that aren't valid in later processes. I don't think that wait for interrupt and yield are... that's odd. Ah, it's because there's some... Yeah, it's not aligned them quite the same way, that's why. And of course, all of the annotations of what the actual instruction was are not there at all. And then on the load store multiples, it's using the shortened form of LDMIA and STMIA, but it's also using the ranged versions, which is quite nice. Push and pop. I'm happy to keep push and pop because they're actually quite nice. RX. It's saying RX number 0. RX doesn't take a parameter because it's an encoding of one of the by zeros. I'm not sure what it is. And that's a instruction barrier, I think it is. So that's come out slightly differently. I mean, that might be, so that the status register stuff might be just a decode problem. That might actually be a bug. I'm not sure. I'm inclined to trust Pyro's decoder because it's based on Capstone, and Capstone is checked by a lot of people, and it's also nowadays using some of the logic from inside OLDB, I think, which it builds in so that it can understand, because it can mirror all the behavior of LLDB, which is quite good. Okay. Many of these are not significant, which is good. Some of them, however, we can do something with. So as I'm looking at it, LDM and STMAA, I think it would be nice to get those into the original RISC OS form. I mean, that's one of the things that I do. The capstone does produce LDM and STM there. So that is a common thing. Let's have a... Yeah, let's have a go at this. So let's go back to the editor. Can we go to Sublime? Here we are. So if I'm going to turn the STMs into STMIAs, we want to be able to do that. As Gerph suggests, a real test would be to disassemble the binary and assemble it back and diff the binaries. Well, that would test things, but it wouldn't test all the instructions. The reason for these tests is so that we actually try and hit many of the different encoding formats that you otherwise might not come across. There's many encoding formats that would never be hit by a compiled generated code, for example. So it's useful to be able to disassemble them. But also, some of them are quite fine to have the comments on the end and not. So, yeah, 6 one and a half dozen the other there. Let's have a look at the LDMs then. Rodis. Yes, I could actually step through every single thing. All 2 to the power 32 instructions. I decided not to do that. Right. So this code here already replaces SVC with SWI because that's one that we expect on RISC OS to be shown that way. So let's see if we can do LDM and STM. So David has said that Darren Salt's Debugger Plus has loads of enhancements we could compare against. Yep, it does, and I have a ticket in here to match ourselves up to that parity. RISC OS Pyromaniac's Debugger also implements a bunch of those. There's a lot of them, which are some of which are quite useful, others of which are a bit weird. But yeah, we could definitely compare against that as well. And in some cases, there's things that I've not thought of and he hadn't thought of and aren't done elsewhere that we could try and add as well, which would be quite nice. Hopefully, we can actually make this code useful so that other people can edit it as well and add things into it. So let's have a look at LDM and STM. And NEMONIC bracket 3 not equal to I, and right. LDM, NE, STM, etc. Okay. CC. So let's copy the condition code. CC bracket not equals. The CC bracket but only if that's actually been set. Can I write to that block? Oh no, this is my block. That's fine. Yes, that's easy, isn't it? That's just actually all I want to do is struct IA onto the end of it, don't I? There's a bit of confusion here about where the NE goes because of how I've modified some of them and not others. That's not ideal. Yeah. Struct NEMC IA. I think that's all I need. Non-character. Oh, that's not how you write strings. Do a new output from this and see what we get. Yep. Yep, so now the only difference is the ranged characters here. The ranged characters here. That's good. I'd like to make this to use ranges as well because it's quite nice to be able to see that. Which one should we tweak next? Right, let's see if we can sort out these conditions. Sorry, not conditions, the PC relative addresses, because they're quite ugly. It's not particularly helpful to have those there. And we should be able to calculate them. These should be a relatively easy thing to do. I'm saying it should be relatively easy. I'm not actually sure about that. Let's have a see. So, the structure that we get back here is D. Where's D defined? Oh, it's a DARM T, okay. And then we decode that into a string, okay. So if I have a look in the DARM header, for a DARM T. Condition flags. Post indexed. The PKH instruction. What the heck is a PKH instruction? Packed half word combines a half word of its first operand with the other half word of its shifted second operand. Well, okay. Okay. I feel so out of touch. I have never even seen that before. Shows how much I know. It's also a conditional instruction, which is interesting. I should probably have that in the list of decoded things, because, yeah, I didn't know that. Interesting. I feel so very dumb. Okay. Where was I? I was expecting one of these to actually have something that says this is PC relative. I haven't seen it. Find. Well, unless it's part of the that one specifies whether it's negative. Is it part of the DARM reg? Nope, they just literally specified as the register numbers. Okay. Go back to the internal, not the internal one, but the table. So these are the encoding types. UFlag just seems to be whether it's up or down. You know what? Presumably, whoever wrote this will have put it, the code that recognizes it, into the DARM_str function. And somewhere in there will be a hash plus. Oh. Append immediate. I could tweak the base code, but then that I don't really want to be changing the original DARM code. I know I already have to make it C89 compliant, but yeah, thumb instructions. Immediate value D. Back to the I think I know what I'm going to try and do. All right, so let's go back to Rodis again. Because we definitely have the args there. If args bit tacky, but does the job. This is a PC relative instruction like B, BL, BLX, or conditional variant. So, we know the address we're decoding for, because we've got the address there. So the immediate value, so that means that I want to create a new args. Master new args. Should be big enough. I'm sure it'll be big enough. Printf into new args d to im d to immediate. Actually, let's just make that a bit bigger just in case. Oops. Right. Address -8 plus d immediate, and then args equals new args. Give that a whirl. Oh, it would help if I built the code first, wouldn't it? Build the code. Doesn't work. 93. I presume. Yeah, that's right. It's the immediate constant. It's d in there. That's all right. Oh, yeah, all right. Let's just fix that. Long rerun it. And reload the file. Bother. It wasn't -8, it should have been +8. Okay, let's go back to where we were. Yeah. Yes, of course, because the address that you're actually dealing with as the PC is the location +8. That's not going to work because I haven't built the code. Build code. Test code. That's not the right key. Not on Windows. Reload, yes, and okay. All right. Does that look okay? Would we prefer to see it without the zeros at the beginning? I actually think maybe we would. However, for consistency, I'm just going to make it use OX 8 and put the zeros in. 08X. There we go. Build and run. Back to here. Reload. Okay, those look good. Let's go back up a bit further. So we've still got some of these here with the LDRs. And these ADRs as well have got to be tweaked as well. That's probably not such a big deal either. Actually, it probably only applies to ADR. Yeah, because I don't think that ADR needs to have anything else, so that might be a special case there. That's okay, let's do that. Very similar to this. One of the things that is in Darren Salt's Debugger Plus is the option to have the mnemonics uppercase or lowercase. So that would be this section here could be just tweaked to allow for that. I'm just thinking if I put this up here, it might make it a little bit easier to see, because then this is the ensure mnemonics. Case. If string comp this is a This is a ADRA with PC relative reference. So string copy the string from args into new args. Okay. Hash plus if str find in the new arguments that we've copied the string hash plus if it exists, because it might not. It might be something that's gone wrong. We then want to go and replace it with the same sort of thing as that. In fact, exactly the same as that, I think. But we don't want to write it at the beginning of the string, we want to write it just at the place we've just found. There. Okay. Build and test. Ooh, didn't work. And I forgot an and. Yeah, that built correctly. Yes, reload. Interesting. On those instructions, it's coming up with a different ADRA. It's 8 too far forwards. "32-bit ARM is just so crazy at times. So I don't need to apply this 8 correction in this case. Right, have a look again. Why are they different? I probably have to honour the U bit, as David had mentioned previously, sorry, Jeff had mentioned previously. Yeah, I probably have to do that. Is that right? That's weird. Why am I... Surely I should only be getting it the same or different there. Sort of confused as to why that's not working. let me go back to this again. So that's the, yeah, so it looks like there's a, I need to take account of the U. Yeah, it just looks like I need to actually check for that bit not being set and make it negative if so. Okay. Oh, sorry, wrong button. D.U. What do we think? I'm thinking this is going to work. Let's just do this. That seems worse. I wonder if they've put the unset value as being the one that's true. That's in the internals, isn't it? Was it in here? Was it in DOM? The unset. Unset is 0. Oh. Yeah. Yeah, that's right. That should be right, shouldn't it? Now I've got them. There we go. That's what it is. I know what it is. I know what it is. It should be accounting for the address plus 8. ARM 32, it's weird. Or maybe I'm just too dumb to be able to understand the encodings. Reload it and same address, same address, same address. Thank God for that. All right. So that's that bit done. There's the capitalization of these and the RX number 0. Yeah, not a big deal. These OXs, trying to make them into hex numbers. I think I'm going to do a replacement on that. And actually, that's probably really easy to do. And then I should try and just have a tweak at these ones, which is also quite easy to do, I think. Okay, let's have a go at just putting the ampersands in the right place. If we found one of those, if arg is not equal to new args, copy it, all the way around. Sorry, I'm not explaining what I'm doing. I apologize. I'm getting myself all distracted. So I'm going to go and cause the OX part of the string to be replaced. Although having found it, I'm now going to have to tweak where it is. So memmove 0x equals offset equals memmove first write the ampersand in, so args bracket offset equals ampersand. Then move all the characters down one, so move into args bracket offset plus 1 from args bracket offset plus 2 of length, oh, how long? I could just do a struct copy because we know the copy is going to go forwards. Since we know this copy is going to go forwards, that's safe. It's probably not the best of code, but it's still going to be working, I think. Yeah, there we go. Yeah, missed me semicolon. Oh yeah, I can't write to it as that. But I can write to it as new args, and we know it already exists in new args, so we'll do that. Okay, have a look at the disassembly, reload. We've now got some ampersands. That's quite nice. Ampersands, no ampersands on that because they're not necessary, not necessary. Shall I just see if I can do the LSL and LSRs? Ooh, I've missed this one. Store PC relative. That looks like the same style of thing as we've got with the other one. That looks like exactly the same style as Adra. Okay. Yeah, okay. I think that's easy to fix as well then. So this is very similar to this code. LDR or STR. Oh, yeah. I also want to check whether it's PC relative, because if it's not PC relative, we shouldn't be doing it. And Strastra. No, not mnemonic. Args. Wrote PC common number. Some of this we could be doing using bit checking and actually just checking what the actual instruction type is. But I'm being kind of lazy here, kind of just trying to get it to work. Yeah, it might be more useful to actually use the bit check to check the opcodes properly. But again, that could be done separately. Same pattern, find where the hash is, replace it with that, and we know that it's got to end with a bracket at the end of it. Okay then. Maybe not. 103. Oh, I missed a bracket. Yeah, you're quite right. Down here. And then have a look at the diffs again. Oh no, no, that's not right. No, that's stupid. I didn't need to do. Addresses are correct, but the values are just garbage. So I didn't need to copy it or do the hash plus or anything of that. I just can do an sprintf straight into new args. And therefore I don't need the bracket. Huh. Right, how does that look? Oh, all right, so I did actually need the beginning of that string because I need the register number. As Homer might say, oh! Undo, undo, undo! Right. Try that again. bracket PC. Please tell me that this is right. I'm going to call it a day after this, I think, because I think we're at a better place now with the disassembly. There's still the MSRs to have a look at because they're not working properly. Right, loads and stores are now in the right place. Okay, not done the mobs yet, but I think that can be another day's work. Yeah, we'll continue with this bit later. Maybe do the capitalization of these LSL, LSRs as well. All right, let's go get that committed. So PC relative instructions and hex values. That's really what we fixed this time. Oh, and the RDMIAs. Closer to this. The LDM STM instructions now expanded to LDM IA STM. The LDR PC relative traces, the STR, the ADR instructions what was the other one? Oh, the constants that use OX are now changed to 1%. Good. All right, let's just push that as it is, and I think we are good with that. Hi Paolo, I'm literally just finishing. So what have we got done today? We've done the prefetch abort handler. We've got that prefetch abort handler now handles the breakpoint instruction. The breakpoint instruction dispatches into debug. Debug can execute some commands. Star continue marks the flag as we can do this and execute the next command, and then goes and executes it, returning to the correct mode. And having done all of that, that's finished the debugging commands, and I've just spent a little while tidying up the disassembly output so that it looks a lot more tidy, more like RISC OS output. So this is the actual output we've got here. This is what Pyro's giving me with my modified disassembly, and this is the output we're getting from the new debugger. There's some very slight differences in the commenting. Some of them are doing hex at a different breakpoint. That's fine. And there was a little bit of oddity here with the MOV instructions, that the Pyromaniac one automatically goes and converts these. I haven't done that conversion here. That can be made to happen as well. Yeah, comments, some capitalizations slightly different. Little bit of difference in the flags here, not a big deal with that. Set end, set engine, that's interesting. That's a never instruction, that's why. What else we got differences here? Oh yeah, there's a little difference that the comp.p tech.p thing isn't decoded in this disassembly. Interesting, but not particularly useful. More significant is the status register, which when we try and manipulate it, it just doesn't seem to understand, which is rather odd. We'll have a look into that and see what's going on. And then finally, there's a little bit of oddity in how the output is for the ranges here, but otherwise we're pretty good. So, I think I feel comfortable with that. I'll probably go and tag it as well. So we just have a look at this and go git tag. What tags have we got here? Oh, I probably need to do a vmanage increment. Increment the version number. We're now 1.05. Oh, new debugging commands. Push that, tag it with the 0.05. There we go. So that's now tagged. It'll take about 10-15 minutes for that to build. So once it has built and I've got something that's working, I will go and make the release, which just means filling in the right values and describing what the changes are. Yeah. Working okay. We're still in the process, if we just come over to the tasks, of comparing the output to the Pyromaniac test, which is also putting some of the disassembly operands a bit more nicely. So let's also move that over here as well, because we're doing both of those things. Next week, if I'm doing it, we will also, come on, move over here, thank you. We'll also have a look at finishing this and maybe look at the FBA instructions. We'll have a see how we get on. Anybody who has any comments on this, any more information and stuff, please feel free to either stick stuff on the issues on the main project, so on DARM itself. There's also the discussions. So if you're a user on GitHub, you can start a new discussion, which is not an issue. It's just ask some questions, which is something I've never used before. But feel free to use that. I will post something up on the RISC OS open forums to say what we've achieved today, and I will try to elicit some other input from people there as well. Can't guarantee that I'll actually get any, but I'll try nonetheless. All right. Have a good afternoon. It's nice and sunny here and relatively warm, so I think you should be able to enjoy your day. See you all later, and I'll let you know when I'm next doing this. Might be next week, might be the week after. We'll have a see. Bye.